So let me start. We are discussing related to process vs thread. So mostly topics I cover here is what is process, what is thread, and what are different types of thread. Okay, mostly I cover here is these three topics. Otherwise, I can say only two topics: process and threads. So the main purpose of process is, first before going to the process, first we have to know the our architecture. We have CPU and memory and other things. Okay, process is memory having certain address. Now here memory is RAM memory I am considering instead of hard disk. So RAM contain some memory like 4 GB and 16 GB something. So from that memory we are taking certain subset of memory and making this memory which is subset of RAM, we are making as a process. The reason why we are taking as a subset will explain. So as of now, this is a memory which is subset of main RAM memory, and this having the address from address and to address. So each process having certain range of memory address. Okay, now coming to the why we needed, we are making subset. So we are making our we have in our CPU, or otherwise in our system we have multiple applications. So for each application there is we have to run. So it takes some memory, from the RAM. So by making the concept of isolation, we make that one app will not take the data from the other app. So app 1 we are giving this address, app 2 we are giving this address. So app 1 feel like it is running individually inside our system. No one can take my data from this app. So it can make app 1 means each app can feel like that it is running as a isolation. No one can interfere from one process to other process. So we have process management is there. Process management will check any process which is running and taking the data from other process, means outside is its range. Then process manager will kill that process because it is because it we, because here there is no isolation concept is means this application is not maintaining the isolation topic. That's why process manager will kill the process. So the main purpose is to make each application run individually in isolated manner. So that's the main concept here. This is the RAM. Each process will take its memory and each one run individually, either parallel we cannot say, but individually each one can run. No one can interfere from one process to another process. That is the main. Next, coming to the thread. Before thread, so this is the process memory. Process memory, which is a virtual memory, subset memory of RAM. Now who is executing this process, this memory? Actually CPU. I will explain details later this topic But CPU, for the CPU also we are making virtual CPU is nothing but the thread. Means a thread contain the data whatever CPU contain, like a registers, whatever CPU contain, the same copy, exact copy will present in the thread. Why we needed the concept of thread, I will explain. Mostly to maintain the responsiveness. Each thread is CPU state. So CPU, instead of running in one exe, CPU can run multiple exe to make our application is a responsive application and reliable application. To make our application is responsive, so CPU is running multiple .exe. So where those state previous, this exe now changed to next exe1, next exe2, next exe, like that it is changing. So whatever the registers data which is available, where it is stored, actually it is stored in the state. Got it now? These data whatever CPU is state, whenever exe is CPU is running the exe1, means it is taking the data from any one state belonging to particular exe. When it is changed to exe2, that means it take any one state or thread and it retrieve the data related to this exe register data which is stored in thread. Okay, so virtualization of CPU is nothing but thread. Coming So this is my process. This process contain multiple thread, but there will be the main thread. This is the main thread which create the subset child thread. This main thread is actually the CPU. Actually this is the virtualization of memory and thread is the virtualization of CPU. How we are doing the virtualization of CPU? Just one, in process we take one object, that object as a stack data structure, stack object. This stack object will be the thread, and this will be the thread which store the details of CPU register. Okay, so now what are the things available in process? Suppose our ASP.NET Core web application or console application, it is a exe file. This exe is executable. Who is executing thread? It uses multiple DLS, mostly in our application. Suppose data DLL, business DLL, logging DLL. So you got it now. So all these execution and DLL will this is the actual executable code, means code. So these code exe and DLL all will take some memory in the process. I can say this is the core memory, and remaining memory you can say as a heap memory, stack memory. One point I missed related to process. So suppose two process need to communicate. We have mechanism like through sockets and through inter-process communication, and through sharing data we can communicate each process. Directly process 1 cannot come to get data from process 2. So question is, who is getting the data from process 1 to process 2? That is executable. Executable means someone need to execute. That is, executable is nothing but thread is the executable of code. You got it now? So any process without thread, that means that process is not executing in CPU. So process manager will check this is for this process, is there any thread is alive? If thread is not alive, that means it is not executing in any CPU. So why we have to keep in RAM? RAM means in memory. So unnecessary memory is wasting to that process. That's why process manager will remove that process which is not available, which doesn't contain any active or alive thread. So you got it now point. Now I explain just basically the what is the process and what is the thread. Process is nothing but virtualization of the RAM, and thread is nothing but the virtualization of the CPU which is executing. So process manager will check if any thread is inactive. If any one thread is not in active mode, then exe will then process manager will kill that process, because unnecessary it is taking the memory. That memory is not used by the CPU for any one purpose for execution. Okay, now I explained what are the actually we have different types of threads in a process. You take this process in runtime, one contain main thread is it is used for executing the starting of the exe by the CPU through main thread. In and finally, and then during the some period of time, main thread will create different threads for, so we can give each thread their responsibility. Now mostly I have one important thing here discuss is exe and dll. Lot of dlls are there. I have requirement that I need to run this dll, suppose logging dll to be run individually by its own thread. That means thread is running exe. We have combination. You check thread is running exe and exe plus dll simultaneously, or thread can run only in exe file, dll is run by other thread, like that. So in code, if we are using dll methods library that is run by other thread, how can we design that part? We will discuss. There is a communication thread, we use channeling or something. Now I just explain briefly about how background thread created and it will run individually. Means suppose we have the class, that is logging class. This logging class run by individually, by no one is executing this code to call the start method from other thread. It is run by individually. Then for the purpose we are creating the static constructor to the class. The responsibility of static constructor is it is run whenever this dll is loaded in. This is managed dll of this library is loaded in execution of the code. Means CLR convert this DLL into native code. Whenever loaded this DLL into memory for execution, at the time first it check what are the static constructor are there, then static constructor will be invoked. Note, you know that static constructor will invoke only what one time whenever the library or the class which is loaded in memory. So in that static constructor we are creating the thread object. Okay, now this thread object is creating in the static constructor, and this thread will run independently. Okay, now you got it. So this is the concept background thread, how it is run individually. Now I will just explain that this process contain some memory which is related to the thread. Means thread is also internally the memory only, just concept is virtualization of CPU. This is the memory which is consumed for the threads. Now this remaining memory is contain the data. This data is, yeah, we have one feature. We have stack 1, stack 2. Stack is nothing but thread only, but internally thread concept is stored as a memory. That memory is stack memory. These stack or thread have only access to, we can give the internally also we can give the scopes, just like how process manager will divide the memory into particular process, and each process only responsible to access this their memory. Like that we can able to give the scope that each process contain multiple thread. Each thread have its own responsibility to access particular data, not whole data which is available in the process contain multiple data. So all data is multiple data is there. So we can give the scope, we can give scope that each each thread each thread will have the means actually I forget, each I was in other mode, so I lose the concentration. Actually each thread have the particular data scope. Now we all know that our ASP.NET Core.NET application is run by the CLR.NET application is managed application. Managed application is nothing but we have CLR process. This process will take our DLL which is present in IL code and directly not execute in the in uh, in memory, or directly it is not executable, but CLR will manage which code need to run execute, which code is doesn't need to execute. During that CLR managing the execution of the code, it will convert DLL into executable and load that executable in the process where execution code is stored in the process. As I now discussed, this is the place where executable code is available in the process. Remaining place contain data only, like means heap, stack, something. Okay, you got it now. Process contain memory which store only exe file, then thread memory means indirectly stack, then data memory, like that. Okay, now here CLR, the benefit of CLR is the CLR is assume that CLR itself like one system, one computer. That computer contain multiple process. Like that CLR is a one container, one system contain multiple process. Here process is nothing but app domain. This app domain concept is similar to process, where process making an isolation by giving the range of the virtual address. In the same manner CLR also make the concept of app domain. It is giving the inside the process, it given again subset of process virtualization address. This virtualization of address is nothing but the app domain. The purpose is same, how process is making isolation, same CLR making the app domain is making isolation. So in each app domain it is responsible for each, like process is responsible for only one exe file. In the same manner here Each in app domain is responsible for one execution file. So CLR can run here web application 1, web application 2, web application 3, like that. Each web, not only web application console. So CLR take the responsibility to isolate each executable of the .NET application. So that's the concept behind app domain. Next, next I need to discuss one thing I forgot. One second. Okay, that's mean actually I forgot. Actually one pending thing is process. That statement I said, process without thread is nothing but means process manager will kill that process, because the process, there is no active thread. That means no one is executing this code in the CPU. Then why we have to keep that executable in memory, unnecessary wasting of the memory. That's why we see that our console application, that is exe application, it is executing the code. After executing code, thread CLR will kill this thread. There is no thread available for that exe. That's why our console application will go on away. That's why we have console dot read line. Whenever we are calling this method, that means there is a thread which is executing the main code. That thread go into the waiting mode. Not waiting mode, it is waiting mode. Why waiting mode is, it is waiting for IO operation. IO operation, any user who will insert anything, he need to listen. For that IO operation, this console.read line is waiting. So that's why the thread is in waiting mode. Indirectly, that executable contain the thread which is in running. It is not in dead mode. That's why that application is not killed. So you got it now point. So any one thread which it is in waiting state or running state instead of in dead, then process manager will not kill that, will not remove that process, kill that process, because one thread is executing. It is waiting for some IO operation, either from a console or request something. Now now I explain the, so console, for console application, in the meanwhile, if we make thread dot sleep, that means thread is alive, it is in waiting state, then that console application will not kill. In the same manner, our host object is there. Why you say that host object? What host object? Which is inherited, I explained the lecture. Host object inherited by web application, hosted service, some hosted service. Okay, this host object having a run method. Actually this run method is internally called waiting, make this thread in sleep or waiting mode. Otherwise but here it is using the thread pull thread. I will explain thread pull thread indirectly waiting mode, but it can it can, the thread is not wasted. I will explain laterly the concept of thread pull, but now I can say that here host.run object will block the waiting thread. Okay, wait, block the execution thread, and remaining then it make our application is alive. So host, if host object is web application, there is a main thread is, it is in block mode, that application will not kill. Another thread is there, that one is background or foreground thread. This thread will handling the HTTP request, but main application will not kill, because this thread is in waiting mode. This is the concept behind the applications which run continuously, whereas the console will kill. Okay, that's it. Next we'll explain later topics, but yeah, I forgot. Thread is nothing but replication state of the CPU. Here it is the concept stack. Each stack contains the object. That object is nothing but trace object. We can say stack trace. That's it. Okay, thanks.